Okay, yeah. So we'll go ahead with what we're discussing about switching again.
Yeah.
So one of the main things is today's networks. The backbone is your switch network. So
Yeah.
if you have a network nowadays, the backbone are the switches. So like we said before, what you typically have in an infrastructure, in the modern infrastructure, is you have something like I'll bring this one up. So let's bring browser. What you typically have is you have yeah. What we typically have is we have a Cisco switches.
Yeah.
Connecting to. So if I bring up let's bring up this Cisco switch again. Copy image. So, Damon, can you remind me again of what's the main reason why you use a switch rather than a bridge, or why we use switches in today's network rather than using bridges?
We talk about features.
Features. Nice one.
The switches give you over the bridge.
The bridge. Nice one. So which features again?
We talked about VLANs.
Nice
We talked
one.
about spanning tree.
Yeah.
And a couple of others.
And what does spanning tree do?
Loop avoidance.
Yeah. Loop avoidance at which layer?
On the layer 2.
Layer 2. Why? So what is it that stops loop at layer 3?
That should be a router.
Yeah. So as in what's the technology that stops loops at layer 3 for a router? Because for a router you don't use spanning tree, do you?
No, I don't think.
No, we don't use spanning tree for a router. So there's something let's do this. You've heard of Wireshark before, right?
Sorry?
Wireshark.
Yeah, I've heard of it.
So let's bring Wireshark up now. Let's just take a sample packet, for example. Let's say HTTP. Yeah, here we go. Let's download a sample HTTP packet and let's examine it on Wireshark. So this is important because this brings everything together. So we need spanning tree only on our switches. So we don't configure spanning tree on our routers. Because spanning tree, thanks Wireshark, I will install the update later. Okay, so here we have our layer 2, right?
Yeah.
So we have layer 2 here, Ethernet 2, right?
Yeah.
We have our source MAC address and our destination MAC address, right?
Yeah.
And then you can examine it, bring that up, examine it. And we have our layer 3, which is our router, right?
Yeah.
And then we have a source. What are the addresses on layer 3? What are they called?
IP address.
Nice one, IP address. So it's called IP address. So we have IP address, the source, and the destination, right?
Yeah.
So let's examine this a bit. Let's open the flag. So on the flag, we have something here. Can you see this?
Yeah, time to live.
Exactly, time to leave. It's called time to leave. What does that do?
Okay.
So let's say, for example, let's bring an example. Let's say a good Cisco router. Let's look for a good Cisco router. Good Cisco router. Let's get ourselves a very good looking router. Come on, Google. Give me a really good router. Okay, yeah, this one will do. Yeah, okay, let's copy it. Let's
This
manage
whiteboard, yeah.
Yeah, this one. Come on. Back to. Let's copy. No, not copy link address. Copy image and paint. let's paste that. Oh, okay. Let's get another image. Sorry. The image is not. So let's look for another one. Come on, Google, give me a better one. Let's copy this one. Yeah, there we go. Finally we have a router. So let's say we have a router here.
Yeah.
We have 3 routers.
Okay.
Yeah, so all these 3 routers. Let's say for some reason we'll connect this router to this place.
Yeah.
And we have this one. Okay, yeah, I used the other one again. Then this one, we have this one connecting to this one.
Yeah.
And this one connecting from here to this one. What do we have? We have a loop, right?
Yeah.
We have a loop on this layer 3 network. So let's say a packet were to coming from this place. The packet goes out to this place, and then goes out to this place, and then for some reason there's a routing loop, and then comes back to this place. Time to leave, as the packet is going from this place to this place, time to leave is counting down. So basically, time to leave simply means time to leave. You have this amount of time to leave. If you don't get to your destination between this amount of time, you'll be taken to the back door and you'll be shot. So in other words, if this packet gets to a router, this packet that we're examining on with Wireshark gets to a router, and time to leave is 0, what would the router do? Drop it. You're gone. But on layer 2, can you see anything called time to leave there? So let's minimize. No, there's nothing called time to leave. So a router, the packet itself has an inbuilt loop, not loop prevention, loop stopping protocol.
Yeah.
Because you can only go around for a particular number of time before you're discarded. But for a switch,
can you set that time? You can, right?
No. You can, but you really don't want to be messing with it. You can. Okay. There are some tools that you can use to generate packets.
Okay.
So those tools that you can use to generate packets, sometimes you can generate packets that are not the norm. For example, you have a standard frame. A standard frame has a standard size.
Yeah.
And what's the standard size of a frame? You know what the standard size is?
No.
It's 1,500 KB, I think. Let's see. Standard frame size. Standard. Yeah, I think it's 1,500.
Okay.
Yeah, so it's 1,500, not kilobyte, bytes. So it's 1,500 bytes. So I'll bring this one here. So you see, so it's 1,500 bytes. But then you can configure something called jumbo. I won't go into it today, but you can configure something called jumbo frames that can increase the size of your frames to 9,000.
9,000. Okay.
Yeah. So the same thing. There are some tools that you can use to generate packet, and you can decide your own, packet flags and stuff like that. But then there's a standard. There are some routers that if your frame doesn't fit this standard, they will drop you. Or some switches. There are some routers that if your packet doesn't fit this particular standard, they will drop you, because they will assume that you're malicious.
Yeah.
Yeah. Someone is generating something that's malicious, so they will drop you. But again, so we don't need spanning tree at layer 3, because a loop, you can only go so far before your time to live expires and you're gone.
Yeah.
But on layer 2, we don't have any such technology to prevent loops. So that's why we need something like spanning tree to help us to come into layer 2 and basically take away all our layer 2 loops. So let's go back. So we said the reason why we use switches rather than bridges are because of something called features.
Spanning tree, features.
And we said one feature, said it's VLANs. So 2, you have spanning tree. Set 3, we have, which one did we mention again?
I think it has something to QoS.
Yep, good. And what's QoS? What does QoS do?
Guarantee.
Yeah, exactly. So it basically guarantees a resource. So you're saying you're guaranteeing a resource. And what else did we mention? We mentioned something like port security.
Security, yeah.
Yeah. So lots of, and we said those are just few of the features that modern switches have nowadays. Yeah. Switches nowadays have like lots and lots and lots of features that you can configure. So let's start. Let's take this one, VLANs. What are VLANs? VLANs, what exactly are VLANs? What do they do? What's the purpose of VLANs on the network?
I think they break up collision domains.
Nice one. Very, very nice point by Demon. So Demon says they break up collision domain. So what do you mean? Explain. What do you mean by breaking up collision domain? What does that mean? So someone comes to you and like, I'm not IT literate, you tell your manager, you know, you can get these things called switches and they will help break down a collision domain. It's like, yeah, what are you talking about? So how do you explain that? Break up collision domain, how do you explain that? Because I'll tell you something, you know, one thing that we do as IT people is sometimes we have a lot of terms.
True.
And we throw out lots of terms. And sometimes I just like to dig down to say, okay, what exactly does this term mean? So collision domain, what do you mean by break up collision domain?
We talked about like how do I put it? Like a jam.
Yeah.
Where everybody's trying to communicate.
Yeah, exactly.
So the collision domains, when the VLANs, if you have VLANs breaking up those domains, so it gives you like you're grouping them into separate how do I explain? You're grouping them separately, so like one port is a collision domain on its own. Other ports too are collision domains on their own. So when you have VLANs, they all work in, I really don't know how to put this.
What if I tell you this? What if I tell you this, Damon, and I say this one that I just described is wrong?
Yeah. Which one?
This I said VLANs break up collision domain. So everyone trying to communicate at the same time. If I say that's wrong, what do you think? Why will I say that is wrong? Is there any reason why I'll say that is wrong?
I don't know.
Yeah, I'll tell you the reason why that is wrong. So let's go over this slowly, very slowly. So let's copy this image. Let's go over this very slowly. Yesterday we talked about the evolution of the network, right? From our physical bus, 10-base-5 network, where we have just a physical cable, to our hub, which operates logically like a physical bus. So let's say this is our hub, right? Our normal hub network. We said anytime you see a hub network, just imagine inside it like it's just a physical bus inside. So let's go.
When I said everyone's trying to communicate, in the sense that there's a broadcast, and then everybody's listening to the broadcast.
The word that you missing there, you said break up collision domain. Collision domain. Remember collision domain.
Yeah.
Not broadcast domain. You said collision domain.
Yeah.
So VLANs don't break up collision domains. Switches break up collision domains. So by default, you don't have to configure the VLAN feature on a switch. So let's go back to the beginning. We have our hub, right?
Yeah.
The ports in our hub are like this. How are the ports? I said imagine just a physical cable going behind it at the back, right?
Yeah.
So this is the physical cable going behind it at the back. So let's say this hub. Actually, let's just go control. No, Okay, can't do that. Let's paste it again. Let's go slowly. So let's not rush through this. Let's go through it slowly as possible. So we have one hub here.
Okay.
We have another hub here.
Okay.
For some reason you've connected this one to this one.
Yeah.
So let's make that black cable. We've connected this one to that one. So we said imagine imagine, then let me go, here we go, that's what we want. Imagine a physical bus inside this hub. It's just a fancy device that operates like a physical bus.
Yeah.
And you have all your cables there, right?
Yeah.
They are connecting to just this physical wire, right?
Yeah.
Collision domain means all these ports are sharing this wire for communication.
Yeah.
So whenever this one wants to go out, even though this one is connected here, they are all sharing this wire for communicating with this other hub. So this one wants to communicate with this one here. It's sharing this wire here. It's sharing just this single wire inside the hub.
Yeah.
The same thing with this hub. Let's say, so let's go through it really slowly. The same thing with this hub. Let's say there's a device here, there's a PC here, there's another PC here. Yeah. So this PC here is trying to communicate to this PC here. So the packet comes. So let's go small packet, change the color, let's select it, and then let's select it. So our small frame or packet or whatever comes in here, yeah? It has to share this physical medium that all these other ports are sharing. That is a collision domain.
Yeah.
That is a collision domain. A broadcast domain is something different. A broadcast domain is, a collision domain is this one. Okay. So this one wants to communicate something. It's sharing just this single link here. But a broadcast domain only occurs when this one wants to communicate something that is a broadcast. Okay, so let's go to the switch now. So we have the hub, right? So everything is sharing just this single line inside the hub, right? So let's go back. Let's clear all this one. So we have our switch.
Yeah.
Let's make it a bit larger. And that made it really small. Yeah. Let's have a really large switch. Okay, so we have the switch here. Yep. Forgive that it's blood.
That's alright.
Yeah. But let's use it to demonstrate or want to demonstrate. So yeah, so let's bring up our line. So this port here, they don't have a single cable at the back that all these ports are sharing. Each port has its own cable. Basically, inside. You get the point?
Yeah.
So a switch by default breaks up a collision domain. A switch by default, every port is a collision domain. Remember again, VLAN is something that is a feature that you have to configure.
Yeah.
So by default, every port on the switch is its own separate collision domain. In other words, if it wants to communicate, if a hub wants to communicate, it has to wait to see that line that they are all sharing, that all the ports are sharing, right? I'm trying to listen to say, can I communicate? Is anything communicating? Will there be a collision? But this one doesn't have to listen because they have their own separate wires. Do you get the point? Yeah. So that's the main difference. So that collision domain, something separate, broadcast domain, something separate. But here's the point. By default, if any device that's connected to this switch sends out a broadcast, by default, it will go to every single port on the switch. Exactly. So that means that's where
the VLAN comes in.
Yeah, exactly. That is a broadcast domain because if it does say I want to send a broadcast, that broadcast will go to everyone. And the problem with that is on your switch. So imagine a situation where you have, so let's get rid of this one. So imagine a situation where, and it's not something that we have to imagine. That's the current situation in where I currently work. Just in one single office, the current office that I work. Let me see. So let's say 6 times. I'm sure that we'll probably have more than 90 switches. So imagine a situation where you have, sorry. So let's copy this one. Let's make it smaller. Let's copy this one. So imagine a situation where you have 10 of this.
Yeah.
And a broadcast, this one decides to say, now, broadcasts are really common on the network. Broadcasts are part of communication. We'll get to that in a minute. But, so let's say all these, let's say for some reason, we're not saying that's how they're connected in the real world, but let's say for some reason, they are all interconnected to one another. Yeah? And these are by default. We've not configured any VLANs or anything. If a device that's connected here, decides that, oh, I want to send a communication to the network and I need a broadcast, and says, okay, I'll send out a broadcast now. That broadcast will basically go out of this port, and this switch will be like, oh, hold on, it's a broadcast, and send it out to every single port on the switch, including this port that is connecting to the switch. So the communication will go and go to this port here. It gets to this port, this one will send it out of every of its ports, including the ports that's connecting to the switch. So imagine how many broadcasts, imagine if you now have all these ports have devices connecting to them, and they're all sending out broadcasts like every second. This one is sending out a broadcast. That's basically all your switch is like busy. Your switch cannot do the job, because the job of a switch is to switch, right? Is to switch frames. But when it comes to a point where your switch cannot switch frames, whether they are busy responding to broadcasts and flooding frames, they can't do the job that they're supposed to be doing, because the memory is used up, the processor is used up. You know, because the thing is with these devices is their resources are limited. Every single one of them, whether you have your router, for example, we have a switch here. So let's see which one. Let's try show version. Let's see, show version. Yeah, let's see the version. We're running version 12. Okay, well, that's good. Let's do a show. So the one I want to see is the command to show.
What exactly are you looking for?
The command to show the CPU resource of the switch. Yeah, let's see. Okay, this one says show. Okay, yeah, this one says show processes. Yeah, look at this. CPU utilization for 5 seconds.
5 seconds.
So, in other words, these things have the resources on the switch is limited. The resources on the router is limited. The switch has a particular amount of CPU. It has a particular amount of memory. So if you're having constant broadcast coming in, the switch is really busy with other things that it can't really do what it's supposed to be doing. So you don't want too much broadcast on your network. You don't want that. Actually, I think Cisco's recommendation, if I'm right, is you should not have more than 500 broadcasts. 500 devices in a broadcast domain. That's Cisco's recommendation. Okay, yeah, let's see. Cisco recommendation, broadcast domain size. So Cisco has a recommendation with that, and I think it's 500 devices. I think it's 500 devices. Yeah, I'm not sure. You can probably, the popular I've seen around is 200.
200 was.
Since it's 200, yeah. I think there was a time that they had 500. But yeah, if it's 200, yeah, that's not. Yeah, okay. Let's say 200 devices. So let's say, okay, let's say Cisco recommends 200 devices for a broadcast domain. Now, many networks today have more than 200 devices. So how do you handle that type of a situation where many networks have more than 200 devices? So that's where something like VLANs come in. So again, VLAN don't break up collision domain. Switches and bridges break up collision domain. Thank you. Nice one. So let's delete this and let's put that again. So VLANs, what do they do? So number one, they break what?
Broadcast domains.
Broadcast domains. Nice one. So let's just do a quick demonstration and stuff here. So here's a brand new switch. I've just installed this brand new switch on my network.
Okay.
I've been tasked with creating VLANs on this switch. So let me go options. Need bigger fonts. Let's see, 15. Right. And okay. Yeah, there we go. That's better. Yeah. Okay. So I want to create a VLAN on this switch. What do I do then, man? How do I create a VLAN on this switch? What do I need to do first?
I think it should be on global mode.
Global mode. How do I get to global mode?
Config T.
Thank you. Config T. I'm on global mode. So I want to create a VLAN. What do I do?
Int VLAN.
Int VLAN.
Int VLAN 1, I think.
Yeah. Well, actually, it's like much simpler than that. So what you want is this command here, VLAN. So to create a VLAN on a Cisco switch, all you need is a single command that says VLAN, the number that you want to create. So all you need is to say VLAN hex. So you want to create a VLAN called VLAN 2. All you need to say is VLAN 2, and you create a VLAN called VLAN 2. What if you want to create 10 VLANs at the same time? VLAN 10 to VLAN 20.
I think you just do 10 to 20.
Yep, VLAN, you're correct. VLAN 10 to 20, and you create your VLAN. What if you want to create like VLAN 10, VLAN 15, VLAN 18? What do you do?
Then you have to impute it, like comma 15, comma 18.
Yeah, so let's go back to apply. So VLAN, if I go, let's do this. Let's see our current VLAN on this switch. Show VLAN. So we only have the standard VLANs. By default, there's a VLAN called VLAN 1. Then we have all these other VLANs, which we'll get to like at some other point. So these VLANs, you won't necessarily be you won't be using them mainly like from me of today's network. Well, we'll get more into them later. But just for this purpose, so you have VLAN 1 by default, and by default, every port is a member of VLAN 1. So that's one of the reasons why you can bring a device, bring a PC, and sorry, let me go even control. Yeah, so you can go bring your PC and connect it to your switch. and by default, these devices will be able to communicate with one another if they have have IP addresses on the same network.
Yeah.
Because by default, all these ports are on the same VLANs. So you can basically take out a Cisco switch out of the box and just plug in the same way you do for your Netgear switches at home, and just plug in PCs to them. So far as they have the same IP address, they will be able to communicate. You don't have to configure anything. So switches by default are plug and play. Routers by default, are they plug and play? Can you use the router without configuring anything?
No.
Because even the port on the router by default is shut down.
Sure. Yeah.
So you have to remember to manually unshut it. But this ones are plug. Switches by default, they are plug and play. So let's say I give this PC, I say, okay, let's give it an IP address. Let's say your IP address is 192.168.1.1, and you say we don't even have to give it a default gateway, yeah? Yeah, 192.168.1.1. We say this other PC here, which is PC3, yeah? We say, well, your IP is 192.168.1.2. And then we say, okay, done. By default, these two will communicate with one another. So if I go to this one and I say 192.168.1.1, ping itself. So of course it can ping itself, right?
Yeah.
So if I say ping your fellow friend, can you see? Can ping it. So we've not configured anything on the switch. We've done nothing. We've just plugged the PCs in. Just gave them IP address on the same network. We didn't even give them default gateways, and by default they can communicate because switches by default are plug and play. But will you ever do that in a production environment in the real world?
No.
Why would you want to do that? These switches are expensive. The reason you buy them is for their features. Why would you want to buy them and just plug them without configuring the features on them? That's the reason why you buy them to begin with. Cisco switches are not cheap. They are really expensive.
Yeah, that's why it's hard to come across one.
Yeah, exactly. I mean, think of this one. It's this one, 1,361. Think about that. Look at this one, 2,280, 2,059. So they are not something cheap. You won't want to do this in the real world where you just plug them. What makes them special? What makes companies spend so much money on them? Is because of the features that they have. That's why they are different from our typical Netgear switches or all that. So you go VLAN 2. We just created a VLAN. Go VLAN 3 to 10. Sorry. Yeah, we have to exit. Yeah. So we go VLAN 3 to 10. Let's go VLAN 3. Yeah, this is packet tracer, sorry.
Okay.
Yeah, this packet tracer, sorry. Because packet tracer doesn't support all the commands fully. Yeah, but that's how you create them. So you can actually just go VLAN 3 to 10. And
I think it will work on GNS. So.
Yeah, it will. It will. So, yeah, let me see this one. VLAN 2. No, yeah, sorry, that's packet tracer. That's not the command. So that's how you create your VLANs. So we create our VLANs is the first thing that we want to do. What else do we want to do? The thing that we want to do is to put our ports, right?
Yeah.
We want to put our ports, because by default they are all on VLAN 1.
Yeah.
So what we want to do is we want to say, this port, you're on this VLAN. This port, you're on this VLAN. This port, you're on this VLAN. So after creating all our VLANs, we want to assign our ports to the VLANs that they're supposed to be in. If you ever work like as a network analyst in any organization, one of the popular requests you get are people that want ports on different VLANs. Oh, can we have port 27 changed to VLAN 5? Can we have port 25 moved from VLAN 5 to VLAN 10?
Okay.
Yeah. So how do I assign a VLAN to a port? What do I need to do? I want to assign port 1, fast Ethernet 1 on this switch to VLAN 1. What do I do?
I think that should be switch port.
Yeah, you're right. But which interface do I need to do that from? I have to be on the interface to assign that.
On the fast Ethernet.
Yeah, so I have to be on that interface first. So you said switch ports. I'll help you with the question mark. So switch ports. What else? Switch ports.
Access.
Access. VLAN, right?
Yeah.
That's the only thing next. VLAN. And what?
The port number.
The port number or the VLAN number. It says here, it says VLAN ID of the VLAN when this port is in. So in other words, what it's basically saying, which VLAN do you want this port to be a member of? So what if I type a VLAN here that doesn't exist on the switch? What will happen?
You won't.
So for example, if I go do show VLAN, we have VLAN 1, we have VLAN 2, right?
Yeah.
So what if I type switch port access VLAN 15? What will happen?
Actually, it won't work.
It won't work. Let's try it. Did you see that?
Doesn't exist.
This one.
And it creates VLAN 15.
So that's one thing to be careful of. If you're assigning your switch ports to VLANs and you accidentally type in a VLAN that doesn't exist, it creates it.
Creates it.
So if we go do show VLAN, now we have a VLAN called VLAN 15.
Yeah.
So that's one other way to create VLANs. You don't probably want to create it that way. but if there's a typo and you type a VLAN that doesn't exist, you've just created a new VLAN on that switch.
But you can remove it, right?
Yes. So that's the other one. So how do I remove that? Let's say I'm like, oh, I just made a typo. I want to remove this VLAN. How do I remove that? What do I need to do?
No VLAN.
Good one. That's correct. No VLAN 15. And then VLAN 15 is gone. No more VLAN 15, it's all gone. So that's the way you remove the VLAN. And the other thing to talk about is this when we're talking about VLANs, because this is really important. In any network, there are two types of switch ports. So your switch port can operate in two different modes. You know what those modes are? So let's go back to our paint diagram. So we have all these as switches, right?
Yeah.
So every port on this switch can be in either one of two modes. Which mode is that?
I don't think I know.
Variant of this one, access,
Yeah.
and trunk. Out of that. So what is access? What is trunk? Which ports are access ports? Which trunk are trunk ports? Or which ports are trunk ports?
I think a trunk port is
So see this single VLAN and then this one.
no VLAN. The switches.
Because think about it. Let's say on this switch, let's do a quick scenario here. Let's say on this switch right here, we have VLANs 2, 4, and 6. Yeah? On the switch here. So those are the VLANs that we have on this switch. And let's say we have these VLANs created, you know, on this one also,
Okay.
and on this one, and on this one, and on this one, and on this one, and also on this one. So we have all these VLANs on all these switches.
Yeah.
Now let's say this port here that this device is connected to, this port is on VLAN 2, yeah? And there's another device connected here. So let's go, so that we have another device that's connected to this one. So we have another device there. And this port is on VLAN 2. Yeah. So now you come here and you type in the command. Let's say this one, this device is 192.168.1.1. Yeah. And let's say this one is 192.168.1.2. So you come on this device and you type ping 192.168.1.2. How will this communication get to this device here? So let's see, this is the communication that's going. Actually, we'll do a quick breakdown of that in a minute.
Okay.
Of what actually goes on. So how will this communication go from here to here? Because once this port comes here and enters this port here, there's a sign. If you go here, so basically I go here, let's do this. I go here and I say, interface fast 01, yeah? Yeah, sorry. Interface fast 01, and I say switch port VLAN 2, yeah? Access. Sorry.
Sure.
Access VLAN 2. So now this port is on VLAN 2, right? Fast Ethernet 01. You know what that means? What that means is that there's a sign on this port.
Yeah.
And this is the sign. The sign is that any traffic that enters this port,
Yeah.
it gets marked as VLAN 2. So basically, the traffic comes from this one. So this device, by default, you know, there's always an exception. But by default, this device, this PC doesn't know I'm on VLAN 2 or VLAN anything. It has no idea. It's just like, well, I've been asked to communicate to this IP address.
Yeah.
So it will get to that later. So it goes and packages it, right? And sends it to this. So when it gets to this switch is like, yeah, I've been marked as that I belong to VLAN 2. So I have to put a little mark on you. And the mark that I'll put on you is a very tiny mark. And the mark is you belong to VLAN 2. So it will just mark it with that mark and say, yeah, no matter who you are, you belong to VLAN 2. Yeah. And so when this one comes to this switch gets it, and this switch is like, okay, for some reason it's like, okay, we'll get to that one also later. This one knows, oh, this device is in this direction, it's over here. Let's say for some reason it knows. So it sends it out here. So, but the thing is, what if this port that is connecting this switch to this switch, what if we configure this and say switch port access VLAN 2? Or sorry, switch port access VLAN 4. Which means
that's trunking comes in.
Yeah, exactly. Because this port has to be a trunk. Because multiple VLANs, we have to go past this port. Because maybe there's another device that's connected here that's on VLAN 4. Maybe there's another one that's on here that's on VLAN 4. So if this one wants to communicate with this one, it has to go past this link. If this one wants to communicate with this one, it has to go past this same link. So that means this same link has to be able to carry multiple VLANs. So that's where it comes in. So you have the trunk. But when you're only connecting a single device, usually, again, there's always an exception. An exception to this rule in today's network. Do you know what an exception will be in today's network? So where you want to plug in a PC to a switch, and then you configure that port as a trunk. So the device is a PC, but this port we've configured it as a trunk. In today's network, is really popular. Why would we want to do something like that?
So that if you have to, okay,
virtualization.
Sure.
Because now on this server we may have these are, let's say these are Hyper-V server or a VMware server. On this server we may have 50 different servers on it, and 50 different servers on 50 different VLANs. So that's why this one has to be a trunk. Because now you're connecting a server that has multiple servers in it, and all the servers can belong to different VLANs. But that's for another day. But just know that that's one exception in today's network. So normally, if you're connecting an end device to a switch port, you configure that port as an access port. And if you're connecting a switch to another switch, you configure that port as a trunk. Now, what's the command? So let's go over this one again. Let's go back to let's view all our interfaces. Actually, options, view. Actually, I think we can go view interfaces. Yeah, show port labels. There we go. Thank you. Yeah. So this is fast Ethernet 03, right? And fast Ethernet 03. So let's look at this. Fast Ethernet 03, show the interface. Or let's do this command, show.
Okay.
Let's do show IP interface brick.
Yeah, you just did that.
Yeah. And let's do show VLAN, right? This is not the normal behavior, but again, this is packet tracer, so so it's not always the normal behavior. Because what will happen in the real world is that if you connect a switch to a switch, by default they will configure this port as a trunk. It won't be
by
on
default.
By default, they will configure. So they will auto configure this port as a trunk by themselves. So that's what will happen if we are not working on packet tracer. So you connect a switch to a switch, but even though it configures it by default, you as an administrator, you still want to go in and manually type in and say conf interface fast 03 and go switch port mode. Yeah. So you see these options here: switch port mode, access, trunk, and another option here called dynamic. So by default, in the real world, by default, all the ports on the switch are set to dynamic. So in other words, you plug in a PC, it will dynamically understand that the device at the other hand is a PC. Therefore, I will configure this port as an access port. And if you plug in a switch, it will dynamically recognize that the device on the other hand, is a switch. How do you think you will know that the device at the other end is a switch? How is it that all of a sudden it will know this one is not, this device that's plugged into me is a PC, this one is a switch?
switches, as you said, they're always plug and play.
Yeah.
So that could be a reason.
Yeah, you're right. You're in the right direction. But here's one reason for that. Here's the reason: is that by default, all the switches that you see, by default, they have something here. I know I'm throwing out a lot of information, but don't worry. Don't even try to remember them. Yeah, don't even try to remember them. The thing is, maybe later when you're watching the video later, everything will be making more sense. You know. So don't mind that I'm throwing out a lot of information. This switch is by default. So you plug in this switch to this switch by default every 2 seconds. Every 2 seconds, these switches are sending something out called BPDU. You've probably heard of them before, right?
Yeah.
BPDU, Bridge Protocol Data Unit. Let's see if there's a Wireshark capture for BPDU, so we can see what it looks like. Wireshark captures are interesting things to. Actually, yeah, one way for us to find out is to use spanning tree. Yeah, let's just download this one. So spanning tree. So you see spanning tree BPDU, right?
Yeah.
And you have all these things called BPDU flags and everything. And basically, BPDU is basically this switch is sending a frame. Right? And the frame is basically saying, I'm a switch. This is my MAC address. This is my priority number. We'll get to all that later when we get to spanning tree. A PC doesn't send that out.
Yeah.
So I want you to look at this one. Look at something. I know I'm throwing out a lot of information again. Yeah.
I read it.
Yeah. So I know I'm throwing out a lot of information. But let's go through something together. Let me show you something. Let me disconnect this device. I've disconnected it, right? So let me connect it again. Connect it to fast Ethernet 01, right?
Yeah.
Can you see that light is orange?
Yeah.
So let's go to the switch. Let's see what's going on. It's still orange, you see?
Yeah.
Yep, still orange. That light is orange, still orange. So let's go and so we won't discuss spanning tree today, but I just want to make a point to show you something.
It's now green.
Yeah, now it's green. Now let's talk about how many seconds? 30 seconds, right?
Okay.
Let's talk about 30 seconds. If we really count it, that's about 30 seconds. So again, what I'll do is I'll delete it, and then we'll see what's happening here. So you see fast Ethernet 01, right?
Yeah.
Yeah. So let's do this. So let me delete this link again, and then let me plug in this one to fast Ethernet 01 again. So while I go back to this one and go show spanning tree. Now look at this. Look at the status. I disconnected it. Exactly. What's it listening to? It's listening for something called BPDU. It's listening. Am I going to get a BPDU from the other hand? If I get a BPDU, I know this device is a switch. If I don't get a BPDU, I know this device is an end device. So it's an access port.
Makes sense.
Yeah. So that's basically, so think of access ports. So like for example, if you have a house, let's clear all this one. Let's clear everything. Let's start clear. Let's take away all that beautiful white spot. So let's go. So you have a house. We have all this. We have this lovely street. We have this street, and this street has all these pathways. So you have all these pathways here, and you have all these pathways there. So at the end of this pathway is Damon's house. So you have your house here. David has his own house here. Someone else has his own house here. Someone else has his own house here. So this one that goes to the houses, where someone basically has to walk in and you're going to a house. That is your access port.
Okay.
Because it's just taking you straight to your house. This one that every one of us, no matter which house you're going to, we have to travel on, is the one that is what?
The trunk.
The trunk. Because this one is carrying communication for all of us. So it's carrying all of us. Whether it's Damon, or whether it's David, or whether it's this guy here, or this guy here, we all have to travel on this same road. But now, when we now get to the place where we like, this is where we're going to, we can get off, then we get off to our access port and go to where we're going to. So think of your switch access port and trunk port that way. So again, if you go COMT interface first 01 switch port mode, we have access, so you can configure it as an access port. So in other words, I don't care what the other hand is saying, configure this as an access port. Even if it's sending PPDUs to you, I don't care. This is an access port. Or we can say dynamic. Yeah, you know, you're an intelligent device, a switch, you know, you're not a hub. You can understand what's going on the other hand. Listen to what is going on the other hand. If you hear BPDU is a switch, configure it as a trunk. If you hear, you know, no BPDU, it's an access device, configure it as an access port. You can set that. But you won't want to do that in the real world. Why won't you want to do that in the real world? You hardly find a network administrator that will put his network to dynamically configure ports to access or trunk. You hardly, any network administrator that does that doesn't like to sleep at night. You hardly find a network administrator that does that. Why? Why would no network administrator do that? Why would they not do that? You know, I mean, it sounds interesting. You know, something will just do it automatically for you. Why won't you like something to be automatic? As an IT administrator, is there any reason why? The reason is control. As an IT administrator, you are a control freak. You have to be in control of your network 100% of the time. Well, you try to, you won't actually be in control 100% of the time, but you attempt to be in control of your network 100% of the time. In other words, you are the one telling this device to do B. If you don't tell it to do B, don't do B. I want you to do A. If I don't want you to do A, don't do A. Because otherwise, your device can go out of control, or your network can go out of control really easily. What happens in this type of a network now? Let's see. So you have this one is your trunk port, right? What happens if we say this port, you know, just dynamically configure it? So let's bring up our switch again. We'll go to our labs shortly. Let's bring up lovely switch diagram that we had. Cisco switch again. Cisco switch. Let's look for the lovely switch again, and then let's see. Okay, here we go. Here's the switch again. Like this switch just looks so lovely. So let's delete that. Yeah, here we go. We have a switch again. So as an IT administrator, let's say you're the type of administrator that doesn't like your sleep at night. So for some reason, you've configured this port here. You said, hey, just be dynamic, you know, just go ahead, listen to it. So this one is like, yeah, your user comes, plug in a device here, like, yeah, you're an access port. It gives access to it, right, on the VLAN that you've configured. So you as a network administrator, you're like, someone says, we need a new switch, you know, in our environment, you know. So you go here, let's cut this one. I've cut my switch a little bit, but yeah. So you come here as an IT administrator, you configure this one, you say, yeah, you know, you're dynamic also. So you plug in this switch here, it goes, yeah, I can hear some BPDUs. This device must be a switch. So it's like, yeah, this port is now a trunk, right? So what happens if you allow somebody, you're doing like a, you know, this company sometimes they like to do, take potential customers around their offices, you know. Maybe they're like, yeah, we want to see your office, see how professional you guys are, to know whether we're gonna give you this contract or not. So you take them to your offices, and maybe one of them is an hacker, and he has his own little switch here. He has his own little switch that nobody can see, you know, and then comes on the network and just plugs in this little switch here. Your network goes, yeah, I can hear some BPDUs. This is a trunk port. You know what that means? It means all the communication on every VLAN will go to this guy.
Okay.
So this guy can basically listen to every communication on every VLAN on your network, because a trunk port by default is carrying all VLAN communication. So especially if you set the port to dynamic, it basically goes, can I hear some BPDUs? Yeah, I can hear some BPDUs. You're a trunk port. Here you go. All VLANs go to you also. So if this guy wants to send a packet, maybe this guy is like, I'm on VLAN 4. It's like, yeah, I want to send something that's going to a device on VLAN 4. Maybe it's a broadcast. It comes, yeah, this one goes, oh, you're going to VLAN 4. It will send it out of every port that is configured for VLAN 4 and every port that is a trunk. So it goes, every port that is configured for VLAN 4. Here you go, you know, here's your own copy, here's your own copy. It goes, oh, you're a trunk. I'll send it to you so that you can send it to any device that is on you, that is on VLAN 4.
Yeah.
Then, oh, you're a trunk too. I'll send it to you so you can send it to anything that is on VLAN 4. So it receives it. So let's say this other device comes and is like, oh, I'm on VLAN 5. I want to send a communication to every device on VLAN 5. It goes to this one and says, oh, you're a trunk. Send this device to any port you have configured for VLAN 5. So this guy can basically listen to everything on your network. So you as an administrator, you've lost control of your network.
True.
So you manually, you want to go to every single access port on your network and manually type in switch port mode access.
So you have to do it for all the ports?
But there's a way to simplify it using the range command.
Yeah.
So, okay, just show IP. Oh, okay, there's no need to do. Yeah. You only use do when you're trying to do it from other modes. Okay, so we have fast Ethernet 1, 2, I think 3 is our trunk. So let's say we want to configure fast Ethernet 4 to 20. Those are access ports. So all you need to do is use the range command on this switch. So go interface range. Interface range fast Ethernet 04 hyphen to fast Ethernet 020 and just configure all those ports at the same time. Just go switch port mode access. Done. You're done. By default, they are all access ports now. Not by default. Now you've manually configured them. Say, I don't care, you're an access port. So that's the deal. You understand the deal there? So that's the deal with like managing VLANs and stuff. That's not the whole thing, but that's like part of the thing. I think we'll probably have to pause for now so we can do a bit of some that. So do you have packet trays on your network?
No.
No. So first thing we'll get you to do is, first of all, download packet tracer. So I'll probably send the, let me see, do I have a link for it? I just downloaded one just some minutes ago. Actually, there's a new model that has
I think I should have. What's the latest model?
6.1.
It's 5.3 I have.
Okay. Yeah, you can use that one also. It doesn't matter. You can use 5.2.
Let me see. Do I have the installation? Where is it?
So yeah, let's get packet tracer on your network. So again, you don't really necessarily. I know you're studying for Microsoft mainly, but you don't necessarily need to focus on this. But I mean, if you go for the Hangout, if you come for the Hangout, you still get some things about switches, which you will not be focusing on it now, or you will just understand a few bits and stuff.
I think I'm already enjoying it.
So let's do just a bit of
lab. The installation file.
Yeah. Actually, let me send this link to you also. Okay. So I'll send it to you. This one has the latest version. I think the latest version, one of the advantages is it has it supports the Cisco ASA appliance also. So there you go. So that's the latest. So you find Cisco PT610.exe. So you can download that, and let's do. So what I'll do is, again, I'll try to send you something on your email address. I hope it doesn't bounce.
610, yeah?
Yeah, exactly, 610. So Cisco PT610. That's the one. So we'll just do a bit of VLAN configuration today. Let's configure some VLANs.
What book would you advise? I think there are two books I've seen people talk about. There's one that is O something. Lamley, and there's one other one, Orion or something.
Yeah, I think that one is the Cisco one. Yeah, the one the Cisco one word for by that. Yeah, I know the one you're talking about. The thing again, it depends on your learning style. Okay. Like I explain, my own learning style is one of the things. I'll tell you one of the things of that people face. Maybe you're facing the same thing also. One of the things that many people face when they start studying for any certification or for any materials for any technology or anything like that is they get overloaded with lots of materials. That's one of the things that people face. People face a situation where this one is like, oh, you can use maybe Cybex material, oh, you can use this Cisco material, oh, you can go online and register online, oh, you can go here and do this one, oh, you can do like all these Hangouts ones, oh, you can use this particular one. You know, so there's like lots and overload, and someone is like, which one should I pick? Should I pick this one? Should I pick this one? Should I pick this one? So, which is why my own learning style is kind of like, so you basically have to follow your own learning style. It's kind of like something that I'm like, okay, this is what works for me. When I start learning the technology, I don't like overloading myself with like too much, like, oh, I'm reading this book and I'm trying to go to that book and that video and stuff. I like to get, exactly, it can be confusing. So I like to get, that's why I like to get something like maybe the official Cisco course or the official Microsoft course, where they have a structure and a module, yeah. And I know that, the structure will be like, week 1 we're doing switching, right? And they will teach us switching in week 1, and we'll do the labs of switching in week 1. Week 2 we're doing spanning tree, and they will teach us spanning tree in week 2, and we do the labs in week 2. Week 3 we're doing this one. So after I go through all of that process, no matter how long it is, and go through the whole structure, I want to understand everything, of course, I want to understand everything, but I go through that whole structure. So that way, at least I've been introduced to almost all the topics, because it's an official course. Then after that, then I use all the other ones to fill in the gap. So I may be like, I want to understand more about switching. So I may watch some CBT Nuggets video, or watch some Twin Signal video. Then I'm like, oh, I still want to understand a bit more about switching. Then I may read the Lamley book, or read this other book about just the switching chapter. Then I may be going again. I'm like, oh, maybe something comes up at work. I'm like, I want to understand a bit more about spanning tree. Then I'll watch video of the train signal guy on spanning tree. Then I'll read Lamley's book on spanning tree. So basically, but the thing is, the first one, I have to do something in a structure. That's just the way my mind works.
Yeah.
I have to do it in a structure first, so I don't get confused, I don't get overloaded, so I have to follow that structure first.
Yeah, because even for the Microsoft,
Yeah.
I went to the Born to Learn site,
Yeah.
and I picked up the whole content, everything.
Yeah.
I pasted it on my OneNote page.
Yeah.
So I look at it like, okay, this is what is expected. So that's what I used when I started the first chapter.
Yeah,
till
nice
I
one.
posted.
Nice one. Which is the reason why in the other Hangout, a guy called Zoe was the one that recommended that we use that format, and I agree with him. So basically, because it makes things easy when we tell people to say, just this week, don't read any other thing, don't read any other book. Just go to that Born to Learn website. Just read all those technical articles, whether you understand them or not. Just go through them and read them. Then let's come and discuss them for this week.
Yeah.
So next week you can go and read section 2. We all go and read section 2. We read all those technical articles. Then we all come together and we discuss them. Then the week after, we all go and read that section 3. So it gives people like a structure. So after you finish that, then for me, after I finish that, then I can now use all these other sources that everybody is shouting about to fill in all those gaps. So because there will definitely be gaps that I'm missing. So I'll then use all these other ones to fill in all these other gaps that I'm missing.
Yeah, sure.
So that's like the learning style that I find that works for me. Because there's lots of information in IT nowadays that I can get really overload is like one of the problems nowadays. People get overloaded with just too much stuff.
Sorry, before I forget this.
Yeah.
For the MCSE, is it recommended that I have a router of my own where I configure so I can connect my servers to? And do you think it's good to use a static IP or just leave DHCP to do the work?
And one of the things that I advocate in labs, because it's one other thing, basically like eventually, like I said, you'll be learning like all these things eventually as you go through them. Eventually you start seeing them. Like I did the official Microsoft course, right?
Yeah.
I went through the whole training. Every Saturday I'll travel from Oxford to London. I mean, I live in Oxford now. I work in Oxford. But the cheapest training that I can find is in London. So basically, when I calculated the training, is that if I do the training in Reading, which is not far from Oxford, I'll need to pay like about 2,000 something. Wow. And I calculated, there's a place I can do it, the same official Microsoft course in London, for a really cheap price, for just £1,000. And they will allow me to pay, weekly or monthly. And the other thing is, I calculated that if I go to London every weekend, I'll still have more money left, and I even have money for lunch. So I'm like, rather than go to Reading and spend this crazy money, I'll just go for the one in London. So every Saturday morning for almost a year, every Saturday morning, I'll wake up 6 a.m. in Oxford. Wow. I have to be in London, the training center, by 9 a.m. So I'll wake up 6 a.m., take my bath, catch the first bus, go to the train station, go straight down to London. So I did that whole structure. I didn't understand like many things in the class and everything, but I just did that whole structure. But one loophole that I found in the training is that even Microsoft, they have things they call best practices.
Yeah.
But they don't follow the best practices in the labs. So that was like the loophole that I find. So one of the other things that I try to do in my own labs is to follow best practices. So in the real world, you won't have your server with DHCP.
Yeah.
Your servers in the real world must have static IP addresses.
Okay.
In fact, what you do in the view world, when we get to the DHCP section later, we'll discuss that. When you get to in the view world, you exclude, you have a particular range that you won't even put on your DHCP server.
Yeah.
So that range will be for your servers. You have to manually statically assign them to your servers. Because you don't want a situation where the IP addresses of servers are changing. They have to be stable.
Yeah.
So you try to follow the best practices for your labs also. So if the best practice is to lock down, for example, Microsoft in the lab, they will tell you just disable all firewall. But in the view world, you won't disable all firewall on your server.
Yeah.
You have to manually, so if you're like, oh, I can't communicate between this server and this other server, you have to manually look for the communication that you want to go through the firewall and manually say, I'm allowing this communication to go out and I'm allowing this communication to come in.
Yeah.
So so that's the same way I do in my labs. I don't disable firewalls. I go into the firewall and manually configure them. Because that's what you expect to do in the real world.
Okay, that's a good one. Thank you very much.
No problem. You have packet tracer now.
It's installed now. I've installed it.
So what I'll do is I'll have your. So if you send me your email address again, then I'll send you a PK file that we'll go through for today. So we'll just go through it. Let's see. Actually, let's go for something simpler.
Have you seen the email?
Yeah, I can see it. Yeah, so I'll send you an email now. So let's go. So we didn't talk about VTP today, but we'll probably do it in the lab, and then we'll talk about it after.
What is? Okay. Sorry about that.
No problem. Actually, let me just send you the place. Just go here, go to this location. Actually, just go to that location and download the switching basic file. So if you scroll down, you find the place where it says download advanced switch configuration packet tracer file.
Like, let me see.
So yeah, so you're on that page, right?
Basic of
so if you do a Control F on that switch, on that page, Control F.
Okay.
And type download
advanced switch configuration
packet tracer file. Yeah, so just download that one. So the instructions are also on that page. If we get to, so here's the task. So I'll post the task to you. Yeah, so that's the task. It says you are the administrator at computernetworkingnotes.com. Company have 2 departments, sales and management. You have been given 3 PC for sales, 3 PC in management. You created 2 VLAN, VLAN 10 for sales, VLAN 20 for management. For backup purpose, you have interconnected switch with 1 extra connection. You have 1 router for inter-VLAN communication. Let's start configuration. First, assign IP address to all PCs. To assign IP address. Yeah, so what we'll do today is we won't go that far to be configuring VTP or anything. Let's just take, the table that they gave to us for switch configuration. So they have a table for PC configuration. They have a table for switch configuration. So the one for switch configuration creates the VLANs on the switches and configure the ports that they've listed with so let me go. So if I bring this one to the screen.
Okay.
So let's close this Spencer guy. Go away, Spencer. Go. Yeah. So you have this one, for example, 294 TTL. So if I bring that up now, so that's this one. So that's 296024 TTL switch 1. So if I bring this one down, let me see where switch 1 is. Actually, let me hide my ports. I think the port labels are blocking. Yeah, let me remove that and then close. Yeah, here we go. So yeah, switch 1, switch 2, switch 3. So on switch 1, what you want to do is configure port F01 for VLAN 10, port F02 for VLAN 20, gig 11 for VLAN for trunk, only allow port 10 and 20, only allow VLAN 10 and 20, and gig 12 with switch 2, that the one that connects to switch 2, this one, only allow VLAN 10 and 20. So this one that goes to this router, this port here, configured as a trunk, but only allow it for VLAN 10 and 20. So do you get what you'll be doing? So basically you go through these ports one by one and create these VLANs.
Okay.
Then number 2, assign this port to the required VLAN. You get it?
Yeah.
Yeah. So you do it for switch 1, for switch 2, and switch 3. Leave this one alone for now. So just do switch 1, switch 2, switch 3. Set it up so that each port. So yeah. So you get what we'll be doing, right?
Yeah.
Yeah. So I'll carry on doing the same thing on my machine also. So if you get to any place that you are stuck, that you're not sure of the command, let me know. Then we'll walk through it together. We'll try to make it as quick as possible. Oh, we've got 1 more minute here. We'll probably just spend like maybe just a few more minutes, maybe 5 minutes extra. So let's see how far we can go. If you get stuck, let me know. You can share your screen, then we can go through it together. So feel free to let me know. Get stuck anytime.
No problem. How do you run the gig one?
Yeah, so gig 1.1 doesn't exist. So if you do a show IP interface brief, you only have gig 0.1 and 0.2. So I think that's a typo. So
Okay.
yes, so you do interface gig 0.1. That'll take you to gig 0.1.
Gig 0.1, yeah?
Yeah, so gig 0.1, so that will take you to gig 0.1. And hello, Auntie, I didn't know. Yeah. Okay, check. Okay. So gig 0.1.
Then you configure 10 and 20 on that too as trunk.
Trunk. So that's the other thing, is that the command that you use to configure trunk. So which command will you use to configure trunk?
It'll be mode trunk.
So can you see my screen?
Let me see. Yes.
So if I go to interface,
it's quite low. I can't. It's far. Let me see. Yeah. Okay.
You can see it, right?
Yeah.
Interface gig 0.1. Yeah. So you want to configure as a trunk, switch port mode trunk, right? Then you go switch port question mark. You can see trunk there. Switch port trunk. You can see allowed there.
Okay.
Allowed question mark VLAN. Then the VLAN IDs that you want to allow. VLAN 10.
20.
Again, packet tracer. Oh god. VLAN 10 to 20. Will you work now? Packet tracer now.
So you have to do 10 and then you have to go and do 20 again.
The thing is, I'm not sure if you do VLAN. Yeah, let's do trunk allowed 10. Let's do 20. Let's do show 1. Gig.
Okay.
Yeah, so you can see it's only allowing VLAN 20.
It's only 20.
Yeah, because you have to specify everything at once. So switch point
Trunk.
Allowed VLAN. So packet tracer, yeah, that's one of the limitations. VLAN IDs of the allowed. So let's go 10, 20. Yeah. Then
It won't work.
yeah, it's packet tracer. But you get the point. So actually, so just leave it as VLAN Hall, for example.
Oh yeah.
Yeah. So this is all. So in the view world, you just type VLAN 10 -20, or sorry, comma 20. No hyphen. Yeah. Interface gig 0 to. Yeah, I think I'll probably have to leave now.
Okay.
Then, so what we'll do is let's just complete just that short task of assigning the port, creating the VLANs and assigning the ports to the VLANs. So next week I'll create the event for next week. Next week we'll probably talk about VTP and we'll talk about spanning tree next week.
Okay.
Yeah.
Thank you very much, man. It's been a good.
No, it's alright, man. No problems. Nice one. Yeah. So so tomorrow we'll do the Microsoft one. If you have the chance.
Tomorrow I'm not sure.
Yeah.
Tomorrow, is it tomorrow or Thursday?
Okay. Thursday is the GMT one. Sorry. Is the tomorrow? No, sorry. No, don't join the tomorrow one. Is for the guys in the US region.
Okay. What time? What time would that be?
So that will start at 11:30 at night in UK time. So that will be +3 your time. So that'll probably be almost 3 a.m. So you'll be sleeping. No, don't try to attend that one because you can attend the next one, which is on Thursday, which is the same one.
I might not be available for that Thursday.
Okay.
So
Yeah.
I'll see what I can do for tomorrow.
No, don't worry, they'll be recorded also. So
Okay.
yeah, we'll start recording them from tomorrow.
Okay.
Yeah.
Very great, man. Thank you so much. Thank you so
problem,
much.
sir.
It's been a great session.
Important, man. Yeah. Cheers. Speak to you later.
Yeah. All right, man.
If you get any questions regarding this one, just drop me an email, drop me an email or something.
All right.
Yeah.
Thank you very much.
Okay,
Yeah.
sure.